Good morning. My name is मोहम्मद रहमतुल्लाह, निकनेम कैफ सर है। मैं पढ़ाने जा रहा हूँ जियोमेट्री of 3 portions: 2D, 2D में ही कॉम्प्लेक्स नंबर, वेक्टर्स 3D एंड वेक्टर्स। मैं कोशिश कर रहा कि विदिन 3 आवर 3 to 6 तक इनका टोटल जो बेसिक कॉन्सेप्ट्स है वो वगैरह दे दूं, सच दैट आपको एनडीए में हेल्प करे एज ए मैराथन। मैराथन मैथ्स है, मेरा टॉपिक जियोमेट्री है। ओके, जियोमेट्री में 2D 3D वेक्टर्स पढ़ाना मुझे। 2D का ये एप्लीकेशन है, कॉम्प्लेक्स नंबर को कॉम्प्लेक्स नंबर ही पढ़ाएंगे। तो थोड़ा डिफरेंट वे में हम करेंगे, क्योंकि 3 आवर में ही करने हैं। थोड़ा अलग वे में करेंगे, 2-3 चैप्टर का क्लब करेंगे। तो उससे पहले अबाउट आयोटा पढ़ेंगे। अबाउट आयोटा पढ़ना है। देखो, तो टाइम नहीं है कि ज्यादा मैं ओवरव्यू दे सकता। एक्स स्क्वायर प्लस 1 इक्वल टू 0 अगर सॉल्व करना हो, मेरे पास अभी तक कॉम्प्लेक्स नंबर दैट इज इमेजिनरी थिंग छोड़कर कुछ भी हो तो इसको बोलते हैं नो रियल सॉल्यूशन। नो रियल सॉल्यूशन। नो रियल सॉल्यूशन को आप सिर्फ और सिर्फ इतना भी लिख सकते हैं, नो सॉल्यूशन। जिस तरह किसी का नाम है राम कुमार घनश्याम, मैंने घनश्याम हटा दिया, सिर्फ राम कुमार बोला, आदमी वही है, आदमी चेंज नहीं हुआ। तो नो रियल सॉल्यूशन बोलो और नो सॉल्यूशन बोलो, एक ही बात है। तो एक वायलर मैथमेटिशियन थे, वायलर, तो बोले इसको सॉल्व करेंगे। तो स्टूडेंट बोला कि इसको सॉल्व तो कर नहीं सकते, नो सॉल्यूशन, तो जो भी सॉल्यूशन आएगा उसको नॉन रियल बोलेंगे। ओके, एक्स स्क्वायर माइनस 1 आया, एक्स इक्वल टू प्लस माइनस अंडर रूट माइनस 1, नॉन रियल सॉल्यूशन। नॉन रियल सॉल्यूशन। नॉन रियल सॉल्यूशन के लिए टेक्निकल नेम नॉन रियल का रखा गया इमेजिनरी। सो इमेजिनरी सॉल्यूशन। अभी इमेजिनरी में एक सिंबल है अंडर रूट माइनस 1, इसी को एक सिंबॉलिक मान लिए आयोटा। एक्स प्लस माइनस आयोटा आ गया, जब इक्वेशन में रखेंगे आई स्क्वायर प्लस 1 इक्वल टू 0, आयोटा स्क्वायर, सो आयोटा स्क्वायर इज इक्वल टू -1। So properties of iota. Number one, आयोटा मुझे मिला अंडर -1 एजम्पशन से, राइट। ओके, इसको कहा था हमने से अंडर -1 को, सेकेंड निकाला गया आयोटा स्क्वायर -1, ये भी निकाल लिया गया है। तीसरा आयोटा क्यूब मतलब आयोटा स्क्वायर +1 आयोटा स्क्वायर इंटू आयोटा, आयोटा स्क्वायर -1 इंटू आयोटा, that is minus iota. So iota q is minus iota. And the fourth case, therefore 2 plus 2 iota square into iota square, -1 into -1 plus 1. Iota square is 1. When you will find iota to the 5, you will get again iota. Iota ka power 6, you will get -1. When you will find iota power 7, you will get minus iota. When you will find iota to the power 8, you will get 1. When you will find iota to the power 9, you will get iota. So very very important statement. Iota is periodic with power 4. Iota is periodic with power 4. Very very important statement. So you have to remember these 4 and this statement. You have to remember these 2 things. Okay. Now calculation of iota to the power n. Now I can also write one more property. Iota power 0, iota power 1. Iota power 0 you will remember as 1. Iota plus iota square, iota cube, it will be 0. So iota ka power 1 plus iota ka power 2 plus iota ka power 3 plus iota 4 equal to 0 again. It means 4 consecutive power on iota will be 0. If we add iota with 4 consecutive power, that is iota to the n plus iota to the power n plus 1, iota to the n plus 2, iota to the n plus 3. So you have to remember this. Okay. You should also remember this. Now, suppose that let alpha, iota to the alpha plus iota to the beta, iota to the gamma plus iota to the delta zero. If, in fact, this will be 0 if alpha, beta, gamma, delta are in AP and common difference is not the multiple of 4. common alpha, beta, gamma are 4 consecutive term of AP, arithmetic progressions, and common difference is not the multiple of 4. Okay, so this should be also remembered. Suppose that I have a 3, 5, 3, 8, 7, 9, 4 consecutive term of AP, but if common difference is not power 5, 3, 5, power of iota, that is 3, 5, 7, 9, the 4 consecutive term of an AP, where common difference is not the multiple of 4, it will be 0, because here minus iota, it will be plus iota, it will be minus iota, it will be plus iota, it will cancel to each other. Okay, let's I take 3, 8, so again it will be 0. How? Iota is minus iota, iota square plus 1, sorry, 13 5 18, here it will be 18, iota is plus iota, iota 18 is minus 1, so again it will be 0. So you should remember this. It's a very important, such as power is in AP. These are the 4 terms: alpha, beta, gamma, delta are the 4 consecutive term of an AP, and common difference is not the multiple of 4. Then the sum of this will be 0. Very important. Now calculation of iota to the n. Since iota is periodic with power 4, iota 4 पावर periodic है, इसलिए हम 4 से ही डिवाइड देंगे, तो डिवाइजर 4 होगा. क्वेश्चन क्यों आया? रिमाइंडर आ रहा है, तो यहाँ डिविडेंड n है, डिविडेंड इक्वल डिवाइजर 4 क्वेश्चन क्यू प्लस रिमाइंडर आर्डर टू n इक्वल आर्डर 4q प्लस r, 4q into r to the r, therefore whole to the q to r to the r to the 4 is 1, 1 to the q 1, and this is iota r, right? So you will directly write remainder. Suppose you have to calculate 2000 iota to the 2024 25 slits. So I will divide 2025 with 4 and find the remainder. So it's very easy to find remainder by divisibility methods. So I will divide last 2 digits by 4, it will give the division remainder by 4. Okay. So 4 6 are 24. Remainder is 1. So remainder 1. Iota to the 1. So iota to the 225 is iota to the 5. Iota to the 1. Let's find iota to the power 20, 67. So remainder will be 4 1 the 4 and 4. Remainder will be 3. After dividing by 4 to 67. So after dividing 67 by 4, you will find remainder 3 and iota q, you know, minus iota. Let's find iota minus 267. हेलो अस्सलाम वालेकुम हेलो अस्सलाम वालेकुम ठीक है पढ़ा रहा हूँ हाँ मैं लेट से आया था ना 11:30 बजे हाँ खा लिया ये खाना खा के अब पढ़ाने बैठा हूँ 6 बजे भी लगातार ऑनलाइन है नहीं 6 बजे तक ऑनलाइन है उसके बाद मर्जी होगा तो बैठूंगा मर्जी होगा तो चला जाऊंगा 11:30 बजे अभी किया था फिर खाना खाने गया था हेलो ठीक हो नहीं बाबू ठीक है ना हेलो हाँ तबीयत ठीक है वो लोग का घूमने का आठ minus 267 so 1 upon added to the 267 now you will divide 267 that means you will divide 267 by 4 and find the remainder. It is equivalent to find the remainder to divide the last two digits. अगर तुमने लास्ट टू डिजिट को डिवाइड दिया 267 को जितना रिमाइंडर आएगा उतना ही रिमाइंडर 267 को 4 से डिवाइड देने के बाद आएगा आई रिपीट 267 को 4 से डिवाइड देने के बाद जितना रिमाइंडर आता है सेम रिमाइंडर लास्ट टू डिजिट को दैट इज यहाँ 67 को 4 से देने के बाद आएगा सो 67 को रिमाइंडर 3 आता है now we'll multiply with iota denominator and denominator so in denominator iota and denominator iota the 4 iota the 4 is 1 so it is iota okay right so this is the calculation of iota so you should know about these things about iota okay so about iota I have given you all the things calculation and each and everything now basics of complex number then I will start introduction of 4 chapters simultaneously introduction of 4 chapters simultaneously I'm giving the introduction of complex numbers so introduction of complex numbers complex number means real quantity plus imaginary quantity real quantity is also called real part and this is imaginary quantity it's not imaginary part I am calling imaginary quantity let x is real let x comma y belongs real. Iota is imaginary. So iota y is imaginary quantity. So I will write z as complex number as a z. Complex number as z. Real part or real quantity as a x. Imaginary quantity is iota y. So x is real part. I left the iota. Small. Alone y. y अकेला. आयोटा के साथ नहीं. आयोटास को छोड़कर y को कहेंगे इमेजिनरी पार्ट. इमेजिनरी पार्ट बोलेंगे, राइट. तो रियल पार्ट इमेजिनरी पार्ट आर रियल क्वांटिटी. रियल पार्ट and imaginary part are real quantity. Think about it. Important. Iota y is imaginary. Iota y is imaginary quantity. Imaginary part is real. Okay. Because I have taken xy as a real. Okay. Real number. Any real number. So I cannot give the full definition of real number at this moment because we have very less time. So I will teach like that. So complex number real part. When you say the number which in the form x plus iota y is a complex number, this definition is called illiterate definitions. This is not the correct definition for complex number. Okay. I'm loudly saying that when you say a number of the form x plus iota y is called complex number, this is the illiterate definitions. I repeat, illiterate definitions. Okay. I cannot give you the educated definition at this moment because we don't have much time. You should understand this way so you can do the questions in examinations. So real part, imaginary part. Now, after that, algebra of complex number. Now, one things I will distribute, very, very important. Complex number. There are three portions. One portion is complex number is real number. When curve real number. If complex number let I have for the format a plus b iota. Complex number has the format. Complex number has the format a plus b iota. So when b is equal to 0, it's called real number. Example 0, 1, minus 1 by 2, root 2, minus root 5, etc. B is 0. Now pure imaginary. pure imaginary if it is a equal to 0. The example 0, 0, iota 5, iota root 2, minus iota 7 by 2, etc. Here a is 0. Now imaginary number. Imaginary number when b not equal to 0. If so, imaginary has two things. If a equal to 0, pure imaginary. So this will go to this portion, okay? Here. And if a not equal to 0, example 3 plus b is not 0, a is not 0. 3 plus 2 iota, comma, root 5 minus 2 iota, 7 plus 7 plus 6 by 5 iota, minus 7 plus 2 iota, net 3 iota, etc. So from here I can say that one more important, 0 is real as well as pure imaginary. 0 is real as well as but it is not an imaginary. Zero is real as well as pure imaginary, but it is not an imaginary number. Very important for your NDA. Okay. This question earlier came in advanced JEE main. Now it will come in NDA. So I have completed complex information now. Algebra of complex number. Algebra of complex number. Let z is equal to a plus b iota, z1 a1 plus b1 iota, z2 a2 plus b2 iota, z3 a3 plus b3 iota. Now addition of complex number. Addition of complex numbers. Let z is equal to z1 plus z2. Z is a plus b iota. So A1 plus B1 iota, A2 plus, the definition is real with that with real part, A1 plus A2 plus iota, V1 plus V2. Subtraction of complex number, Z1 minus Z2. So here A plus B iota, here A1 minus A2 iota, V1 minus V2 according to definitions. 3. Multiplication of complex number, Z1 Z2 A plus B iota, A1 A2 minus B1 B2 plus iota A1 B2 A2 B1 . Fourth, equality of complex number, if A plus B iota equals C plus D iota, then A equals C and B equal to D. So equality leads to simultaneous equations. Okay, you have to solve simultaneous equation. A equal to C and B equal to D. We cannot compare complex number. We cannot compare imaginary number. We can't compare imaginary, that is A plus B iota less than C plus D iota, if B equals 0 or B equal to 0 does not exist. Relation doesn't exist. Compare नहीं करने का मतलब less than greater than, that means we cannot do less than equal, less than, greater than or greater than equal to. We cannot do complex number, sorry, imaginary number. We cannot compare imaginary number, right? So think about it. तुम्हें क्वेश्चन आया था एनडीए में, इफ ए प्लस बी आयोटा लेस देन सी प्लस डी आयोटा, देन 4 ऑप्शन थे, टिक करना था. एक ऑप्शन था ए स्क्वायर प्लस सी स्क्वायर, दूसरा ऑप्शन था बी स्क्वायर प्लस डी स्क्वायर, ए स्क्वायर प्लस 0 बी स्क्वायर प्लस डी इक्वल टू 0, तीसरा ऑप्शन ए स्क्वायर प्लस डी स्क्वायर इक्वल टू 0, चौथा ऑप्शन बी एस सी स्क्वायर, बी स्क्वायर प्लस डी स्क्वायर, ए स्क्वायर प्लस डी ए स्क्वायर प्लस सी स्क्वायर. नाउ बी स्क्वायर, no is c square d square. Okay, now a square b square, let's, this will be valid if the condition was given. This will valid if b equal d equal 0, both are 0, then a less than will be valid. Okay, we can compare real number, we can compare real. Compare means which one will be greater and which will be lesser. Okay, which is small, which is large. Compare means, so we can compare real numbers. So B, D both are 0, then we can compare. So it will become both complex number will be real. If I take B 0, then A plus B iota will be real. And if I take D 0, then C plus D iota will be real. So both will be real after taking B and D simultaneously 0. So B square plus D square both are 0, so it will be 0. Option B is the correct options. Okay, right? So think about it. You remember this word, this sentence. We can't compare imaginary numbers. Now the fifth law, conjugate law. Suppose that I have A plus B iota, then conjugate will be A minus B iota. If I have A minus B iota, conjugate will be A plus B iota. A plus B iota conjugate pair. Conjugate of A plus B iota is A minus B iota. A conjugate of A minus B iota is A plus B iota. So these are conjugate pair. So remember these portions. That means when जब हम लोग कंजुगेट लेते हैं तो जो इमेजिनरी पार्ट होता है वो प्लस है तो माइनस करते हैं इमेजिनरी पार्ट वाले, इमेजिनरी क्वांटिटी वाले को। इमेजिनरी क्वांटिटी के आगे अगर प्लस है तो माइनस करते हैं, इमेजिनरी क्वांटिटी अगर माइनस को प्लस कर देते हैं तो मेरा कंजुगेट पेयर आ जाता है। नाउ द सिक्स्थ लॉ इज डिवीजन लॉ। So division law, let I find Z1 upon Z2. It will be A1 A2 plus B1 B2 upon A2 A square plus B2 A square plus minus A1 B2 plus A2 B1 divided by A2 A square plus B2 A square multiply iota. So this is a division law. You have to remember all the 6 law, right? Now properties of additions. First commutative law, Z1 plus Z2 equal Z2 plus Z1. Commutative law. Commutative law. Then associative law Z1, Z2 plus Z3, Z1 plus Z2 plus Z3. Associative law. Additive identity is 0, 0. Z1 plus 0, 0 plus Z1 is Z1. Additive inverse Z plus minus Z 0 minus Z plus Z 0. Right? Now properties of multiplication. additive identity. This is additive inverse. Multiplication property. First is Z1 into Z2 equal Z2 into Z1, commutative law. Zero is called additive identity. Minus Z is the additive inverse of plus Z. Plus Z is the additive inverse of minus Z. Now Z1 multiply Z2, Z3. Z1 multiply Z2 multiply Z3. It's associative law. Third, multiplicative identity. If we multiply Z with iota 1 or 1 with Z, we will get Z. 1 is multiplicative identity. 0 is additive identity. 0 is additive identity. 1 is multiplicative identity. We multiply two complex numbers Z1, Z2 and get 1. देखिए multiplicative inverse. Right? So Z1 is the multiplicative inverse of Z2 and Z2 is the multiplicative inverse of Z1. Right? Now the fifth law, distributive law. Z1, Z2 plus or Z3. I can multiply Z1, Z2 plus Z1, Z3. If we have in middle minus, I can write minus. Okay? I should write minus. Sorry. This is called distributive law. Now one closure property. If we operate complex number together, we will get complex number as a result. We will get complex number as a result. So these are the property of additions, and we don't have properties for subtraction and division. Okay. If we have a subtraction like that, Z1 minus Z2, first of all, before implementing law, mathematical law, whatever I have written, properties for complex, properties for addition of complex number and properties for multiplication of complex number, these are called mathematical law. So when we implement mathematical law for Z1 minus Z2, it will be written as Z1 plus minus Z2, right? Then I will use the mathematical properties. When I use division, first of all, I will convert it into multiplications. Okay. Then I will use the mathematical law. We don't have mathematical law for this. Now, one more important word. Suppose that I have a natural number. The natural number is the proper subset of whole number. Whole number is the proper subset of integer. Integer is the proper subset of rational. Rational is the proper subset of complex number. Sorry, real number. A real number is the proper subset of complex number. Q dash is a irrational number. Irrational number is a proper subset of real numbers. Q dash equal real number union. Q union Q dash is R real number, and Q intersection Q dash is phi. And imaginary is also imaginary number is a proper subset of complex number. Okay, let's see each called complex number. C complex number. N whole number W, sorry, N natural number, W whole number, Z integer, Q rational, R real, C complex number, Q dash irrational, and imaginary number I have written imaginary. Right. These are the now the properties of conjugate. Properties of conjugate. Suppose that I have taken conjugate 2 at a time, then it will eliminate the conjugates. So if we take even number of time conjugate, समझा ना, हम even number of time conjugate लिया तो conjugate खत्म हुआ था जेड आता है, साथ में odd number of time conjugate लेता तो conjugate आता है एक बार, right? सपोज जेड इज इक्वल टू ए प्लस बी आयोटा है, कंजुगेट लेने का तरीका जेड कंजुगेट लाइन खींचा, ए प्लस बी आयोटा लाइन खींचा, इमेजिनरी क्वांटिटी के आगे प्लस था तो माइनस कर दिया, माइनस रहता तो प्लस कर देता. नंबर 2, Z1 प्लस Z2 को कंजुगेट करना तो Z1 का कंजुगेट अलग, प्लस है तो प्लस ही रहेगा बीच में, Z2 का कंजुगेट अलग, Z1 में Z2 का कंजुगेट, Z1 का कंजुगेट माइनस तो माइनस बीच में, Z2 का कंजुगेट अलग. अब मैं पहले वाला का जनरलाइज कर देता कि Z1 प्लस Z2 प्लस Z3 डॉट 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 प्लस और माइनस, पहला और दूसरा दोनों को जनरलाइज करता. प्लस और माइनस प्लस और माइनस प्लस और माइनस and taken the conjugates, so it will be Z1 conjugate plus Z2 conjugate plus Z3 conjugate plus dot 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 plus Zn conjugate. If it will be minus, I will write the minus. Okay. So here I will write rating with plus plus plus. I'm blanking with minus 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 minus. Okay. So मैंने सब प्लस लिया और n टाइम मैंने z को ऐड किया. n टाइम को z ऐड करेंगे तो n z बार n z बार n स्केलर क्वांटिटी है. n is a scalar quantity, right? Now the multiplication, z1 z2 conjugate, z1 का कंजुगेट अलग, z2 का कंजुगेट अलग, इसका जनरलाइज करेंगे z1 z2 z3 डॉट 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 zn conjugate, z1 conjugate, z2 conjugate, z3 conjugate dot dot Zn conjugate. Now the sixth law, based on this generalize, if we multiply Zn times Z to the n conjugate, it will be Z to the n whole conjugate. From here, I will add seventh law. Let's I have a Z capital small f of Z. So when I will take Z conjugate, so it will go inside the functions. Inside the function I can take it. Okay. If then if I have Z1 upon Z2 whole conjugate, Z1 conjugate divided by Z2 conjugate. Ninth, Z plus Z bar you will find 2 times X, that is 2 times real part of Z. X is called real part of Z if we have a Z is equal to X plus iota Y. The Y is called imaginary part of Z. Okay. If Z plus Z bar is 0, it means Z is real. Then Z is real. Z minus Z bar you will find 2 times iota 2 times Y. It is iota 2 times imaginary Z. Here Z is equal to X plus iota Y. Right? Now the 12th, if Z minus Z bar 0, it will also written as Z is equal to Z bar. Here this will also written as Z is equal to minus of Z bar. Then Z is real part 0 1. Then Z is purely imaginary. Then Z is purely imaginary. Then Z is real. Then Z is real. Hold on. Now, one more important word, very, very important for the good questions. Z1, Z2 bar plus Z1 bar Z2 2 times real part of Z1 Z2 bar are equal to 2 times real part of Z1 bar Z2. Right? Any problem? Now let's take last property for conjugates. So the conjugate property. Thank you. Mubarak. If Z is equal to a determinant of Z A1, A2, A3, B1, B2, B3, C1, C2, C3, then A1, B1, A1, A2, A3, B1, B2, B3, C1, C2, C3 are complex numbers. Then Z bar A1 conjugate, Z1 conjugate, A1 conjugate, A2 conjugate, A3 conjugate, B1 conjugate, B2 conjugate, B3 conjugate, C1 conjugate, C2 conjugate, C3 conjugate. So these are the concept for Z inverse. Reciprocals. These are reciprocals. I already told you when the multiplication of those two complex numbers is 1. Z1 and Z2 is the reciprocal of each other. So if I take Z, so Z to the power minus 1 is 1. It is minus 1 upon. This is the reciprocal concept. Okay? Right? Modulus. Argument. Modulus is the magnitude. Modulus magnitude or distance between points. Distance between two points. Argument. Argument is also called amplitude. It is also called polar angle. Okay? Polar angle. Let's I take argon diagram. In argon diagram, x-axis is called real axis. Y-axis is called imaginary axis. Real axis by left I take 1 unit as a 1 and imaginary axis I take 1 unit as a iota. Okay? 2 unit as a 2 iota minus 1 unit as a minus iota minus 2 unit as a minus 2 iota. On real axis plus 2 unit as a 2 minus 1 unit as a minus 1 minus 2 unit as a minus 2. These are the argon diagram. real axis and imaginary axis are perpendicular to each other. Let's I have z is equal to x plus y iota. I will plot this on an Argand diagram plane. Suppose that I have a point P. The coordinate of P is a small x comma y. It will retain in complex form is z. In complex, it will retain as z. So I will draw the perpendicular from P to the real axis and perpendicular from P to the imaginary axis. So from origin, that is the point where real axis and imaginary axis cuts, to PM, point where we draw the perpendicular from P to the real axis. So this will be your x and this will be your iota y, right? So z will be your iota y, but in coordinate form it will be x comma y. Let's join origin with P. Okay. OP length called magnitude of z or modulus of z or z or distance between origin and point P. Origin and point P. OP. I am taking angle theta from positive x-axis to the OP. OP, angle between positive x-axis to theta measured in angle measured in anti-clockwise directions from positive x-axis for principal value. Angle measured in anti-clockwise direction from anti-clockwise directions from positive x-axis for principal value. For principal value, zero less than equal theta less than 2 pi is standard. This is a standard case, okay? Right? So theta is called polar angle or argument of z or amplitude of z. Theta is called. The angle measured in anti-clockwise direction from positive x-axis for principal value, okay? Otherwise, angle always measured from positive x-axis. Angle always measured from positive x-axis. You have to remember it. You have to remember it. Always measure for positive x-axis. Now I have to find OP. Pythagoras theorem, according to OP square, according to Pythagoras, OP square equal OM square plus PM square. So OP square, OM, here length of OM is mod x, length of PM is mod y. Length of OM is mod x, length of PM is mod y. So OM is mod x whole square, PM is mod y square, mod x square is x square, mod y square is y square, because square will always be positive value, so we can eliminate mod for even power. We can eliminate mod for even power. So OP will be always positive. This is the length. This is not the negative value. The length of OP under root x square plus y square. This is called your mod Z. This is called your mod Z. Right? Now, after mod Z, I have to find the theta. Suppose I will now I am drawing a fresh diagram. I will take reference angle alpha. Say theta equal to alpha. What is the tan alpha? Tan alpha you will always find mod y upon x. Alpha equal tan inverse mod y upon x. So alpha will be from 0 to pi by 2. Okay. Suppose polar to Cartesian. Polar to Cartesian you will write. We know the r theta. We know the r theta. I have to find x and y. So cos theta equal x upon r. Mod z also written as r. Okay. And sin theta y upon r. So x equal to r cos theta, y equal to r sin theta. You have to remember for polar to Cartesian. Polar to Cartesian. Remember it. Okay. Now Cartesian to polar. Cartesian to polar. You have xy given, right? You have xy given. Up to find theta, I have to find r. So I already told you r, that is mod z under root x square plus y square. Number one, if point in the first quadrant, if point in first quadrant, then theta equal to alpha. Alpha, I already told you about alpha. Tan inverse mod y upon x. You will always use this. If point in the second, for first, theta equal to alpha. If point in the second, point in second quadrant, this is the alpha. I have to find theta. What have to find? I have to find theta. So theta will be pi minus alpha. Theta will be pi minus alpha. If point in the third, in third quadrant, this is the alpha. I have to find theta from here to here, or from here to here. So theta equal to 2 pi, sorry, pi plus alpha, standard. Theta equal to minus pi plus alpha, non-standard. If minus pi is less than equal theta less than equal pi, non-standard principal value interval. ये क्या है? फैक्चुअल डेटा है, जो स्टैंडर्ड है, जो पहले बुक बुक लिखे, जो स्टार्ट के, जो डिफाइन के, वो प्रिंसिपल एंगल को पॉजिटिव, दैट इज 0 to 2 पाई डिसाइड किया गया, राइट? इसमें कुछ ऑथर, अब छोड़ो, कमेंट करना अच्छी बात नहीं है, वो काम बढ़ा दिए, तो उसने माइनस पाई से पाई, ये भी एक सर्कल लिए, लेकिन आधा सर्कल इसने नेगेटिव लिया, आधा सर्कल पॉजिटिव लिया, एक सर्कल इसने भी लिया, लेकिन फुल सर्कल लेता तो जो पहला वाला सिस्टम स्टैंडर्ड वो ज्यादा बेटर है, फुल सर्कल एंटी क्लॉकवाइज में, और यहाँ जो माइनस पाई से पाई है वो हाफ साइकिल क्लॉकवाइज में और हाफ साइकिल एंटी क्लॉकवाइज में है। ये नॉन स्टैंडर्ड है, तो नॉन स्टैंडर्ड के लिए थर्ड के लिए यही है तुम्हारा, ये वैल्यू है। नाउ पॉइंट इन द फोर्थ क्वाड्रेंट, Point in the fourth quadrant. देखो, ये एंगल निकालना है और ये एंगल निकालना है, लेकिन यही एंगल अल्फा है। तो यहां से अल्फा की मीनिंग ऑलरेडी बता चुका हूं मैं, सब में वही है। थीटा इक्वल टू 2 पाई माइनस अल्फा, स्टैंडर्ड है गए, स्टैंडर्ड। एंड थीटा इक्वल टू माइनस अल्फा नॉन स्टैंडर्ड है। ये प्रिंसिपल वैल्यू निकालना है। क्या निकालना हूं मैं? प्रिंसिपल वैल्यू फॉर प्रिंसिपल वैल्यू ऑफ आर्गुमेंट। और प्रिंसिपल वैल्यू आर्गुमेंट 4 पॉइंट है। पहला पॉइंट फर्स्ट में, दूसरा पॉइंट सेकंड में, थर्ड में है, फोर्थ में। नाउ मेरे पास जेड है एक्स प्लस आयोटा वाई, तो कार्टेशियन फॉर्म कहते हैं। एक्स को लिखेंगे हम, एक्स को ऑलरेडी बता चुका है मैं कि आर कॉस थीटा, वाई को आर साइन थीटा। आर बाहर करो तो कॉस थीटा प्लस आयोटा साइन थीटा, या आर मतलब मॉड जेड, कॉस थीटा प्लस आयोटा साइन थीटा को द ट्रिग्नोमेट्रिक फॉर्म या पोलर फॉर्म। और पोलर फॉर्म ट्रिग्नोमेट्रिक फॉर्म और पोलर फॉर्म, राइट। अभी ऑयलर साहब थे, वो डिफाइन किए ई टू द आयोटा थीटा कॉस थीटा प्लस आयोटा साइन थीटा। तो यहां से जेड आ गया मॉड जेड आयोटा थीटा, राइट। मॉड जेड आयोटा थीटा आ गया। इसको होता है यूलर फॉर्म, आइलर फॉर्म, वाइलर फॉर्म, वाइलर फॉर्म, वाइलर फॉर्म इसको कहते हैं। अब देखो, ई टू द आयोटा थीटा कॉस थीटा प्लस आयोटा साइन थीटा, ई टू द आयोटा थीटा का मैग्नीट्यूड निकाला मैंने, एक्स की जगह कॉस थीटा है तो कॉस स्क्वायर थीटा, और वाई की जगह साइन थीटा है तो साइन स्क्वायर थीटा। कॉस स्क्वायर थीटा प्लस साइन स्क्वायर 1 होता है, 8 8 जगह मॉड 1 आ जाएगा आंसर, याद रखना। ओके, राइट। अबे प्रॉपर्टीज ऑफ मॉडुलस। प्रॉपर्टीज ऑफ मॉडुलस। प्रॉपर्टीज ऑफ मॉडुलस में कभी भी मॉड जीरो और जीरो से ज्यादा होगा, नेगेटिव हो ही नहीं सकता। एक मुझे कंजुगेट में लिखना सोच रहा था, मैं छोड़ रहा था, छोड़ इसलिए दिया, मॉड नहीं पढ़ा था। अब मॉड पढ़ा देंगे तो मॉड और कंजुगेट के बीच मिला करेगा तो जेड जेड बार मॉड जेड स्क्वायर है। जेड जेड बार मॉड जेड स्क्वायर आता है। तीसरा, मॉड माइनस मॉड जेड को कंपेयर किया रियल पार्ट ऑफ जेड से, you always less than equal, always less than mod z as well as, and ये भी साथ में होता इमेजिनरी पार्ट ऑफ z लेस देन इक्वल टू mod z, राइट। आगे चल के ज्योमेट्री देखेंगे तो पता चल जाएगा कि z का मॉड लो या माइनस z का मॉड लो या z बार का मॉड लो या माइनस ऑफ z बार का मॉड लो, सबका मॉड इक्वल होता है। क्या होता है? सबका मॉड इक्वल आता है। फिफ्थ लॉ, z1 z2 का मॉड किया तो z1 का मॉड अलग, z2 का मॉड अलग। सिक्स्थ, अगर मैं z1 z2 z3 डॉट 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 zn तो मॉड z1 मॉड z2 मॉड z3 डॉट डॉट मॉड zn, सर ये नंबर नहीं इसको, अगर इसी में z1 z2 z3 को सबको z रख दूं तो z को n टाइम मल्टीप्लाई z मॉड z का पावर n, फिर मॉड ऑफ z टू द n या मॉड z टू द पावर n, दोनों सेम आ जाएगा स्पेशल केस से। ओके, राइट। बाद 8 नंबर में डिवीजन लॉ है, मॉड z1 z2 ऊपर का मॉड ऊपर नीचे का मॉड नीचे, राइट। के बाद तुम्हारा एक ट्रायंगुलर प्रॉपर्टी, वेरी वेरी इंपॉर्टेंट, ज्यादा डील कर नहीं सकते लेकिन लिख देता मैं, मॉड ऑफ मॉड z1 माइनस मॉड z2 लेस देन इक्वल टू मॉड z1 प्लस माइनस लेस देन इक्वल टू मॉड z1 प्लस मॉड z2। ओके, तो मॉड की प्रॉपर्टी इतनी काफी है। उसके बाद आर्गुमेंट की प्रॉपर्टी, जो आर्गुमेंट था, प्रॉपर्टी जो मॉडुलस था, प्रॉपर्टी जो आर्गुमेंट, प्रॉपर्टी जो आर्गुमेंट, दो तीन प्रॉपर्टी पढ़ेंगे इसमें, ज्यादा नहीं। आर्क z1 z2 निकालना हो, आर्क z1 प्लस आर्क z2 निकाल लेंगे। दो कॉम्प्लेक्स को मल्टीप्लाई करके आर्गुमेंट निकालना है, दोनों के अलग अलग आर्गुमेंट को ऐड कर तो बराबर हो जाएगा। आर्ग z1, सॉरी, आर्ग z को n टाइम मल्टीप्लाई किया तो बेटर है n आर्ग z, अरे z1 डिवाइड बाय z2, तो बेटर है डिवाइड देने से आर्ग z1 निकाल लो माइनस आर्ग z2 कर दो, आंसर आ जाएगा। प्रॉपर्टी ऑफ आर्गुमेंट, क्या आएगा? प्रॉपर्टीज ऑफ आर्गुमेंट आ जाएगा। कुछ दो चार प्रॉपर्टीज और भी लिख देते हैं इंपॉर्टेंट। आठ जेड बार करना है तो दो होंगे, पाई आएंगे। जेड इज नेगेटिव रियल, नेगेटिव रियल माइनस आर्ग जेड एफ जेड इमेजिनरी एंड जीरो जेड इज पॉजिटिव रियल। जेड पॉजिटिव रियल तो जीरो, और जेड बार में इंपॉर्टेंट प्रॉपर्टी है, याद रखो। हाँ हेलो, शहबाज को या किसी को भेजो सबको ऊपर। वो मीटिंग बंद हो गई, मीटिंग स्टार्ट हुआ है, कहाँ पे टेलीकास्ट हुआ था मुझे तो मालूम नहीं। शहबाज को जल्दी, फोन नहीं उठा रहा है कोई। शहबाज फोन क्यों नहीं उठा रहा था? नहीं, शहबाज क्यों नहीं फोन उठा रहा था, नहीं समझ आ रहा। चला गया? अच्छा। मार्टिंग अभी ये बंद हो गया, चालू हुआ कहाँ पे टेलीकास्ट हो रहा था मुझे मालूम है, यूट्यूब पे जा रहा था। नहीं, यूट्यूब पे नहीं, यूट्यूब पे जा रहा था, बोला तो और से पूछ चालू है, सब चालू। अभी मैं अपने आप चालू है। नेट का प्रॉब्लम, कनेक्शन लूज होगा ना, हाँ, तो ऐसा होता। तो मुझे तो शेयर तो कर दूंगा, मुझे तो कोई दिक्कत नहीं। ठीक है, कुछ नहीं, अभी टेंशन मत लो,
वो
अगर
ले-
ऐसा होगा ना,
हाँ,
तो समझो नेट का प्रॉब्लम है खाली।
नहीं ना, बंद हो गया फिर चालू हुआ था।
हाँ, रिकरिंग होगा,
तो यूट्यूब फिर वो यूट्यूब यूट्यूब में बंद नहीं ना होता है।
नहीं होता, नहीं
तो उसको बोलो अभी ये चार्जर लेके भेजो, खत्म हो गया। चार्जर लेके आओ जल्दी, चार्ज रिचार्ज करने के लिए जल्दी। तो वो मैं प्रॉपर्टी जॉब कॉम्प्लेक्स की बात कर रहा था, इसमें प्रॉपर्टी आर्गुमेंट कर रहा था मैं। हमें एक दो और प्रॉपर्टीज कर लेता, इफ आर एग्जेट जीरो है और पाई है, देन जेड इज रियल। दूसरा, इफ आर एग्जेड पावर टू आर माइनस पावर टू है, देन जेड इज प्योरली इमेजिनरी। जेड प्योरली इमेजिनरी है। अगला प्रॉपर्टी है आर्ग जेड, आर्ग जेड बार आर्ग जेड माइनस आर्ग जेड बार। तो अगर आर्ग जेड जीरो से ज्यादा है तो पाई आता है, आर जेड अगर जीरो से कम लेंगे तो नेगेटिव आता है, माइनस पाई आता है। ये इंपॉर्टेंट है प्रॉपर्टीज। ट्वेल्थ, एक दो और छोटे छोटे प्रॉपर्टी लिख लो। कि मॉड जेड वन प्लस जेड टू, मॉड ऑफ जेड वन प्लस मॉड ऑफ जेड वन प्लस जेड टू इक्वल मॉड ऑफ जेड वन प्लस मॉड ऑफ जेड टू। देन हर जेड वन हर जेड टू बराबर होगा हर जेड वन इक्वल कोलिनियर इन द सेम डायरेक्शन। सो कहते कोलिनियर इन द सेम डायरेक्शन। दूसरा, मॉड ऑफ जेड वन प्लस जेड टू मॉड ऑफ जेड वन माइनस जेड टू, दोनों बराबर होते। इसका मतलब ये हुआ कि आर्क जेड वन जेड टू के बीच पाई बाय टू एंगल है। आर्क जेड वन बाय जेड टू, दैट इज आर्क जेड वन जेड टू आर्क जेड वन माइनस ये पाई बाय टू आएगा, याद रखना। ओके, राइट। के बाद एक चीज और है, मैं आगे जाऊंगा तो बता ही दूंगा, लेकिन अभी एक इंपॉर्टेंट बता दो, Z-Z1 मॉड Z-Z2 मॉड का कर ले रहा के। यहाँ पे के अगर 1 है तो स्ट्रेट लाइन, और के नॉट इक्वल टू 1 है तो सर्कल हमेशा आते हैं। एग्जाम्पल के लिए Z-5 आयोटा अपॉन Z+5 आयोटा, टू लिया बोलेंगे सर्कल, क्या बोलेंगे? सर्कल बोलेंगे। एक Z-5 आयोटा Z+5 आयोटा 1 लेंगे। स्ट्रेट लाइन है, या स्ट्रेट लाइन कौन सा होगा? अगर Z1 और Z2 प्योर इमेजिनरी है तो यहाँ पैरेलल टू एक्स एक्सिस या एक्स एक्सिस ही होगा, मतलब रियल एक्सिस है ये। क्या है? ये रियल एक्सिस ही है, निकालने के बाद पता चलेगा। राइट, आर्गुमेंट की प्रॉपर्टी हो गई। तो डिमूवियस थ्योरम्स, उसके बाद डिमूवियर्स डीई डिमूवियर्स डीई MOIVEVRES थ्योरम। डिमूवियस थ्योरम में cos थीटा रेशनल है, क्या है? cos थीटा प्लस आयोटा साइन थीटा n है cos n थीटा प्लस आयोटा साइन n थीटा। n जो है वो लेट्स टेक नेचुरल नंबर। एक चीज याद रखना, ई टू द पावर आयोटा थीटा cos थीटा प्लस आयोटा साइन थीटा है, ई टू द माइनस आयोटा थीटा cos थीटा माइनस आयोटा साइन थीटा होगा ई टू द पावर 2 k पाई आयोटा 2 k पाई, ये तुम्हारा 1 आएगा, याद रखना। आयोटा पाई बाई 2 आयोटा आएगा, सब याद रखना। ओके, दूसरा cos थीटा प्लस आयोटा साइन थीटा n है cos 2 k पाई प्लस थीटा डिवाइडेड बाय n प्लस आयोटा साइन 2 k पाई प्लस थीटा बाय n। n की वैल्यू 0 1 2 से लेकर n-1 तक, वेयर n इज फ्रैक्शन और नेगेटिव। फ्रैक्शन और नेगेटिव, in fact the p by q fraction, so n is denominator of p by q, N is denominator of P by Q. N. So this is a very important things you have to remember. Okay, and these have to be the very simple things you already remembered it. Now cube root of unity. Cube roots of unity. Cube roots of unity. Let's suppose that cube root of 1. When you will find z is equal to 1 or omega square. What is the omega? Omega will be minus 1 plus root 3 iota by 2 omega square minus root 3 iota by 2. When you will find cube root of minus 1, you will get z first root minus 1 or minus omega square. Okay, right? Properties of omega. Omega is power 3. That is 1 plus omega square 0. Omega q is 1. So when you will write omega to the power n, it is a periodic with power 3. I will divide by 3. So quotient is q, remainder is r. So n is equal to 3q plus r. So omega to the power 3q plus r, 3q omega to the r. Omega is 1, 1 to the q is 1. So omega to the power r, you have to write it. So I can extend the 1 plus omega square property. So we write 1 plus omega to the power r, 1 plus r is not the multiple of 3. 1 plus omega to the r plus 2r. You have two results. One result 0. R is not the multiple of 3. R is not the and 3 if R is multiple of 3. So these are the very important results you have to remember for examinations. That means 1 plus omega to the 6 plus omega to the 12, you will find 3. 1 plus omega to the 5 plus omega to the 10, you will get 0. Right? Omega to the power 3r is 1 because it's periodic with power 3. 3r plus 1, you will get omega. Omega to 3r plus 2, you will get omega square. Omega conjugate is omega square and omega square conjugate is omega. So remember it, these things. Okay. Cube root of omega form the equilateral triangle. Here 1 root 1 comma 0, second root omega. Omega is minus 1 by 2 root 3 by 2 iota plus minus 1 by 2 minus root 3 by 2. So this is the omega point. This is the omega square point. Now we'll join the when you find the length of the sides of triangle root 3, root 3, root 3. So equilateral triangle. Equilateral triangle. When you join with this vertex, with the center of the circle, will form 120 degree, 120 degree, 120 degree. So circumference divided into three equal parts. Circumference divided into 3 equal parts and form the equilateral triangle. The side length is root 3. Okay. Now the square root of complex number, then application will be come after. Suppose that I want to find 12 plus 5 iota square root. So when you will find the with the help of procedure or with the help of formula, it's your choice, but I will not go with that. I will complete a plus b होल स्क्वायर a minus b n स्क्वायर. मतलब ये है कि जब आयोटा के साथ प्लस हो तो a plus b होल स्क्वायर कंप्लीट करूंगा, आयोटा के साथ माइनस हो तो a minus b होल स्क्वायर कंप्लीट आंसर आ जाएगा. यहाँ पे 2ab के लिए आयोटा के साथ 2 फैक्टर से 2 फैक्टर नहीं तो 2 से मल्टीप्लाई किया, 2 से डिवाइड दिया, 2 into 5 तो आयोटा और 12 into 2 24 हो गया. अब यहाँ पे 2ab 2 की जगह 2 है, a की जगह मैंने 5 लिया, 5 का स्क्वायर होता है 25 और b की जगह आयोटा है, b की जगह आयोटा है तो आयोटा स्क्वायर माइनस 1 होता है तो 25 माइनस 1 24 होता है. 24 दिख रहा है मुझे तो इसको मैंने दो जगह बांट दिए. 25 माइनस 1 प्लस 2 into 5 into iota divided 2. तो 5 स्क्वायर माइनस 1 को आयोटा स्क्वायर प्लस 2 into 5 into iota 5 plus iota whole square by 5 ये होता है प्लस माइनस 5 iota, sorry, in the denominator we have 2 not 5. divided by root 2. This is your square root. So if you have 12 minus 5 iota, 5 iota, you will directly find plus minus 5 iota by root 2. Should remember square root of root iota. It will be plus minus 1 plus iota by root 2, and under root minus iota should plus minus 1 minus iota by root 2. So remember these things. These two things you should remember it. In your examination, there was 12 plus 5 iota in the September attempt, plus 12 minus 5 iota. So I can directly write, let's I take positive value for both. 5 plus iota by root 2 plus 5 minus iota by root 2. So it will be 2 times 5 by root 2. So it will be 5 root 2. This was the correct answer in your examinations. Okay. Now I will find one square root again. So I want to find the square root of let's say take minus 7 plus 24 iota. Let's say take. Suppose that here minus. So minus, I will split 24. So 24 into 4 into 3. 2 is already in the factor of 2ab. So if I write 4 square and 3 iota square, you will get 7 as a positive. But here 7 as a negative. So if you write 3 iota square plus minus 7, sorry, if you write 4 iota square, 3, if you write 3 square plus 4 iota square, you will get your result minus 7. Okay. So I will put for minus 7, I will write 9 minus 16 minus 2 into 3 into 4 iota. I can write 9 as a 3 square minus 16 as a 4 iota square minus 2 times 3 into 4 iota. So you will get 3 minus 4 iota to the whole square. So you will get your result plus minus 3 minus 4 iota. Right? Any problem? You can find results of the square root by shortcut. Suppose that one more thing, then I will go on to 4 basic chapters. Okay. So let's try and multiply with the help of De Morgan's. Suppose Z1 x1 plus iota 1. I will write as it is at mod Z1 is the iota theta 1. Z2 x2 plus iota y2. I will write in mod Z2 into the iota theta 2. When we write Z1 Z2, so it will be mod Z1 mod Z2. Will if we multiply, power will add. So iota to the iota theta 1 plus theta 2. Let's divide Z1 by Z2. So mod Z1 into the iota theta 1 mod Z2 into the iota theta 2. So it will be mod Z1 upon mod Z2. When we divide, power will subtract. So theta 1 minus theta 2. Okay, that's enough for the complex number. Number one point concept of rotation. Concept of rotation. Suppose that I have a complex number Z1, another complex number Z2. I have rotated to some angle. Let's take alpha. With the conditions length of AB equal length of AC. Length of AB is mod Z2 minus Z1. Length of AC is mod Z3 minus Z1. Right? So let's I write Z3 minus Z1. So it will be mod Z3 minus Z1. Okay. हेलो वालेकुम सलाम बोलिए मार्केटिंग हाँ मैं 7-8 बजे तक आ जाऊँ 7-8 बजे तक मैं तो बस से आऊंगा हाँ वहाँ पहुँच जाओ मैं वहां से नजदीक है तुम्हें तो मैं इससे पहुंच जाऊंगा बस या ऑटो लेके पहुंच जाओ किसको किसको दोनों का मिला के 300 दिए क्या नहीं समझ में 300 मुझे भी दिए 300 तुम्हें भी दिए ओके ठीक हाँ ठीक sorry here will write let is making angle theta 1 and z2 minus z1 let's this will be z3 z2 minus z1 mod the angle making theta 2 so let's I divide z3 minus z1 divided by z2 minus z1 so mod of z3 minus z1 3 oh yeah and z2 minus z1 mod here e to the power theta 1 e to the power theta 2 z3 minus z1 upon z2 minus z1 because z3 minus z1 mod and z2 minus z1 cancel each other these are equal e to the power theta 1 minus theta 2 so the result will be z3 minus z1 divided by z2 minus z1 e to the power theta 1 minus theta 2 so this is the rotation if lengths are equal if lengths are not equal the magnitude will remain as it is that means if if mod of Z3 minus Z1 not equal mod of Z2 minus Z1, then Z3 minus Z1 divided by Z2 minus Z1 equal mod of Z3 minus Z1 mod of Z2 minus Z1 angle between the, sorry, that is angle of rotation. Angle of rotation. So take care about these things in complex number. Okay. Now I'm going to start introduction to T2D. Introduction to 3D vectors and application of vectors. Sorry, and application of complex number. And first of all, distance between 2 points in 2D. For 2D, x1, y1, x2, y2. So PQ in 2D is under root x1 minus x2 whole square plus y1 minus y2 whole square. Let this is a complex number z1. This is a complex number z2. So PQ will be mod z1 minus z2 or mod z2 minus z1. Let's, I have the origin O and OP is the position vector and OQ is the position vector. And I have to find PQ. So according to triangle law, OP vector plus PQ vector, OQ vector. So PQ vector equal position vector of OQ minus position vector of OP. So magnitude of PQ is PQ, okay? Right? Here OP vector, point P is x1, y1, so x1 I cap is unit vector in the x direction, j cap is the unit vector in the y direction. Think about it, okay? And OQ vector x2 I cap, y2 j cap. Now OQ vector minus OP vector is already you are getting. So PQ vector you will find OQ minus OP. So x2 minus x1 I cap, I2 minus y1 j cap. So this is the distance between 2 points You can also write this as a x2 minus x1 whole square y2 minus y1 whole square. Now I have a 3D points PQ and position vector is x1, 2.x2. Okay. So for 3D, distance between 2 points under root x minus 2 whole square y minus y2 whole square plus z1 minus z2 whole square. These are the things. Okay. Now 3D in the x direction unit vector is I cap, z direction, y direction is j cap, and z direction is k cap. So we will write OP vector as a x1 I cap, y1 j cap, z1 k cap. OQ vector as 2 I cap, y2 j cap, z2 k cap. Okay. Think about it. So x2 minus x1 x2 whole square, y1 is whole z2 z1 is z2 whole square. Now this is the magnitude of PQ. Should remember that one thing, complex number is a 2D vector. Complex number is a 2D two dimension, 3D मतलब 3 dimension, 2D मतलब 2 dimension vector quantity. So 3D in 3D we cannot represent complex number. In 3D we cannot represent complex number. I repeat. Here you can write PQ vector as for 3D OP vector minus OP vector. So it will be x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. Now, slope of a line. Let theta angle made by theta angle made by PQ with positive x-axis in anti-clockwise directions. The slope equal dy by dx equal m equal tan of angle theta equal, let's I take y2, then y2 minus y1 upon x2 minus x1, or let's I take y1 minus y2 upon, then in the denominator x1 minus x2. These are the form of plus slope. Right? So suppose that this is the suppose that this is the Z1, Z2, right? So iota imaginary part of iota or सीधा or directly imaginary part of Z1 minus Z2 and real part of or imaginary part of Z2 minus Z1, real part of Z2 minus Z1. You will get the slope. Okay, right? Complex form, coordinate form, right? Slope of the line. Now 1.0 vector, magnitude 0, direction not specified, direction undefined, unit vector, magnitude unity, and direction the direction in which we are finding the vector, and the direction in which we are finding a unit vector. let's let this is a vector r. I want r cap unit vector in the direction of r vector. It will be r vector divided by magnitude of r. That means if we divide vector by r magnitude, then the direction will not destroy. Direction remain as it is. So r cap, r magnitude is r vector. I vector, I cap is the unit vector along the positive x-axis. Y cap is the unit vector along the positive axis. J cap is the unit vector along z-axis, right? And position vector. Position vector is the vector point with respect to origin. Vector of a point with respect to origin. Let this is the P point. OP is position vector. Position vector of OP. Position vector of P. A vector with respect to origin. Right? If we draw perpendicular on x-axis, here theta, this is y. X projection of OP along x-axis. So x component along x-axis. Along x-axis by projection of this is the OM. Projection of OP along y-axis. That is component of OP along y-axis. Theta is the polar angle. I told you OP is the length. So OP vector is, suppose that first of all OM vector. OM is along the x-axis, so component of x-axis will multiply with I cap. ON is vector along the y-axis. So ON vector along y-axis, I will multiply y component with j cap, and here OP vector equal OM vector plus ON vector according to triangle law. Here OM vector MP vector equal to ON vector, right? So for the with the triangle law, I will go O to M vector, then M to P vector in order, then in opposite order closing side will be your OP vector, okay? Right? And now OP vector, this is xi cap, this is yj cap, Cartesian form. Now OP vector, x is in polar coordinate r cos theta I cap, y is r sin theta in polar coordinates, okay? J cap, r is common, cos theta I cap, sin theta j cap, r is magnitude of OP. So magnitude of OP r cos theta I cap, sin theta j cap. So OP vector divided by, this is the OP vector, polar form. OP vector magnitude of OP cos theta I cap, sin theta j cap. So this is OP cap, unit vector along OP vector. Unit vector along OP vector cos theta I cap, sin theta j cap. Because magnitude of OP cap is under root x component square plus y component square. This will be your 1. Okay. So you have to remember these things. This is a 2D. Now one more thing, one more thing to go. Let's take first of all the basics of vector and 3D. Then we'll go to the section formula. Okay. This is a 2D. Now position vector you have already learned. The position vectors. Now one more things. Parallel vectors, collinear vectors. Parallel vectors or coincident vectors. For both, parallel vector is like vector, unlike vector, like vector, unlike vector. And for like vector is positive vector, sorry, equal vector, and this is here negative vector, right? I cannot do the I cannot give you the definitions. I will only I will only draw the diagram. So lead in the same direction like vector, same directions like vector, in the same direction equal magnitude, equal vector, in the opposite directions unlike vector, in opposite directions negative vectors, on the same line of actions, same line of actions, coincident vectors, same directions like vector, opposite directions unlike vector, equal magnitude, positive vectors. So let's A vector and B vector are two vectors. So A vector equal lambda times B vector. A vector and B vector are called collinear vectors. Lambda 1, that is direction same, magnitude same, like equal vector. More than 0, like vector. Less than 0, unlike vector, in opposite directions. And lambda minus 1, negative vectors. These are the negative vectors. If ML control a line L1 and line L2 are parallel. Line L1 and line L2 are parallel, right? Suppose that line has A1 x B1 y plus C1 0 line 1 A2 x plus B2 y line L2. M1 equal to M2 means A1 by A2 equal B1 by B2 parallel line. I will extend this. If A1 by A2 equal B1 by B2 equal C1 by C2, I will call it is as a parallel, not equal. And A1 by A2 equal B1 by B2 equal C1 by C2, coincident. Called coincident. This is parallel. Parallel means we have two meanings. That lines have the same orientations. That means same inclination. Parallel means same inclinations. Same inclination. Same inclination can be with the separate distance, with the distance between each other. So that's called parallel. And both lines running to each other on each other. Then this is called coincident line. Okay. Now one more important I will teach you. Perpendicular lines. Slope of one line is, let's m1. Slope of another line is m2. If m1 m2 minus 1, then lines are perpendicular. Lines are perpendicular. Now angle between two lines two lines between two lines. If theta is acute angle, theta, then theta equal to tan inverse modulus of m1 minus m2 upon 1 plus. So this is the formula to find the acute angles. Okay. What is the obtuse angle? The obtuse angle will be pi minus theta. The obtuse angle will be pi minus theta. Okay. Now we'll go a little bit further. Pi minus theta, obtuse angle. Now introduction of vector and 3D frame. Let this is the x-axis, the y-axis, along this z-axis. We have a vector x, y, z, right? The angle made with the positive x-axis, positive y-axis, and positive z axis. Alpha, beta, gamma is the angle made by OP with positive x-axis, comma, negative, comma, positive y-axis and positive z-axis. Alpha, comma, beta and gamma are called direction angles. If OP is directed line, that is OP vector, then cos alpha, comma, cos beta and cos gamma are called direction cosine cosines of OP vector. Direction cosine is unique. One more important word. Direction cosine is unique. If OP is non-directed line, we have two set of direction angles, alpha, beta, gamma and pi minus alpha, pi minus beta, pi minus gamma. So two set of direction cosine. Two set of direction cosines. Direction cosine unique for directed line. I am saying direction cosine is unique for directed line. Non-directed line has two set of direction cosines. So that's an angle. So two set of direction cosine. So that will be cos alpha, cos beta, cos gamma and cos pi minus alpha is minus cos alpha, cos pi minus is minus cos gamma, cos beta, cos pi minus beta is minus cos beta, cos pi minus cos gamma, these two sets. Now direction here L is equal to cos alpha, M equal to cos beta and is equal to cos gamma, right? Direction ratio will be directly proportional to direction cosine. Direction ratios will be directly proportional to direction cosine. Let A, B, C are direction cosines, the direction ratios of a line along x-axis, y-axis and z-axis. Right? L cos alpha, M cos beta, N cos gamma are DCs, direction cosines. Direction ratio is DRs. So DCs along positive x-axis, positive x-axis, positive y-axis, and positive z-axis. That is, इसका मतलब ये हुआ A is directly proportional to L, so I will write as A equal to KL. B is directly proportional to M. Action ratios are directly proportional to direction cosines. So B directly proportional to M. So B is Km. C is directly proportional to N. So C equal to Kn. Right? Now, suppose I have a directed line OP. I will draw perpendicular on x-axis. This is the angle of alpha, and this will be your x. We'll draw the perpendicular on this. This is the angle beta, and this will be your y. And this will be your angle gamma, and draw the perpendicular z. X, y, z are projection or component of OP vector along not positive axis, axis but along x axis. From here, you will take cos alpha. The base is x, and the hypotenuse is, let's OP is R. So R, so X equal to R cos alpha and cos beta. This is L. So LR cos beta, perpendicular is, sorry, base is Y for cos beta and hypotenuse is R. So this is M. So I will write Y equal R cos beta or MR. This is X axis. This is Y axis. I already written the value, so we by understood. And N is equal to cos gamma equal, for cos gamma, for gamma base is Z and hypotenuse is R. So Z equal to R cos gamma or NR, right? Distance between OP mom and note that OP, you have remembered it, root x square plus y square plus z square by the distance formula. So OP is R, OP is R square plus y square plus z square, squaring both sides, R square equal square plus y square plus z square. Now put x equal to R cos alpha square, R cos beta whole square, R cos gamma whole square. So R square will cancel both sides, cos square alpha, cos square beta, cos square gamma equal to 1. You have to remember these things. From this I can derive sin square alpha sin square alpha, sin square beta, sin square gamma equal to 1. I can derive, right? So technically cos alpha is L square, cos beta is M square plus N square equal to 1. You have to remember it. We have A equal to KL, B equal to KM, C equal to Kn. Put in the equations. Yeah, the square and add A square plus B square plus C square. So K square common, L square plus M square plus N square. L square plus M square plus N square is 1. So this is K square. K is plus minus under root A square plus B square plus C square. From here I can write L equal to A by K. So plus minus A upon under root A square plus B square plus C square. M equal to B by K. Can write here from. So plus minus B upon under root A square plus B square plus C square. And M equal to C by K plus minus C upon. The action cosine is unique. Cosines are unique. So I will take only one set. L is equal to A upon A square plus B square plus C square.
n equal to b upon under root square plus b square plus c square, and n equal to b upon under root a square plus b square plus c square. Hold on 1 minute. For 1 minute, I will come.
वो अगला टीचर 6 बजे आ रहा है कि नहीं? ये 7 बजे एक्सटेंड कर देंगे। पूछ लो आएंगे तो ठीक है, तो मैं 7 बजे एक्सटेंड कर रहा हूँ, ठीक है। नहीं नहीं नहीं, मैं ऑन ऑफ नहीं करूंगा, मैं बोल रहा हूँ अगर नहीं आएंगे तो मैं 7 बजे तक एक्सटेंड कर सकता। पूछ लो आने वाले तो ठीक है, तो एक्सटेंड कर देता हूँ। So L is this L square projections. These are the things. Now the basics 3D, basics 2D has been cleared. Now start section points. Section points. Suppose that this is the point P in complex number term Z1. In vector, this is the A vector Z. This is the Q in complex number Z2. In vector B vector in 2D x2 comma y2 in 2D x1 comma y1. Okay, let the complex number, this is Z, this is R vector, or in 2D this is x comma y. To find this, let PR by QR M by N. So M will multiply with Q, or Q will multiply with P. So for 2D, X will be more MX2, for internal plus NX1 upon M plus N, and Y equal My2 plus Ny1 upon M plus N for internal. For complex number Z, the mz2 plus nz1 upon m plus n. For vectors, r vector, ma vector, sorry, mb vector, m is multiplied with b vector, na vector divided by m plus n. And for 3D, let's point P, x1, y1, z1, point Q, x2, y2, z2, and R, x1, y, z. Then x will remain as it is mx2, nx1, m plus n. For 3D, y equal to my2 plus ny1, m plus n, mz2, nz1, m plus n. Right? This is the 3D. So I have written for vector, for complex number, and for 2D. The let's take m by n is 1. So m by n is lambda. Lambda is to 1. Again P Z1 a vector x1 y1 for 3D x1 y1 z1 x1 y1 z1 q z2 b vector x1 y1 sorry x2 y2 r x2 y2 z2. Let section point r z r vector a vector r vector b vector are position vectors. Okay, so this is for x comma y comma z or xy. Here p by r q by r is lambda is to 1. So this is lambda from here to here. From here to here 1. Earlier, from this point to this point m, from this point to this point n. Okay. Now lambda will multiply with q, 1 will multiply with p. Okay, so for 2D x equal lambda times x2 1 into y into x1 upon lambda plus 1 and y equal lambda y2 plus y1 upon lambda plus 1. Now the next point, is I want z, so lambda z2 plus z1 upon lambda plus 1, and I want vector r vector, so lambda b vector plus a vector divided by lambda plus 1. And for 3D x equal to lambda x2 plus x1 upon lambda plus 1 and y equal lambda y2 plus y1 upon lambda plus 1 and z is equal to lambda z2 plus z1 upon lambda plus 1. Okay, understood this, right? Now the first formula The MN formula I will use to find points. This formula I will use to find point, and this formula used to find ratio. Used to find ratio, right? Now middle point, midpoint. हाँ मानसी मैम, मैं 7 बजे तक हूँ, उसके बाद किसी को भेज दीजिएगा। 7 बजे बाद सत सर का अभी से फोन करके है। हाँ 7 बजे तक। हाँ, रुक, आधा आधा घंटा 1 घंटा रुक, 1 घंटा। 6:55, 7 बजे रुक, 7 बजे आऊँ। मिड पॉइंट, लेट सपोज that P point complex number Z, vector as a vector, 2D as a x1 comma y1, 3D as a x1 comma y1 comma z1, Q point at a complex number z2 as a vector b vector, position vector, and a 2D x2 y2 and a 3D x2 y2 z2. R complex number z, vector as a r vector, 2D as x comma y, 3D x comma y comma z. So these two are equal length, PR equal QR. देखो इसमें क्या था, पहले वाले में पॉइंट से सेक्शन पॉइंट तक एम, पॉइंट से सेक्शन पॉइंट, फर्स्ट पॉइंट पी है, फर्स्ट पॉइंट का मीनिंग होता है फर्स्ट पॉइंट से सेक्शन पॉइंट तक एम। सेकेंड पॉइंट क्यू है तो उसका सेक्शन पॉइंट तक एम। जो पहले कॉल किया था जो पॉइंट को उसको फर्स्ट पॉइंट कहते हैं, जो सेकेंड कॉल किया था उसको सेकेंड पॉइंट कहते हैं। यहाँ पे फर्स्ट सेकेंड का बहुत ही इंपॉर्टेंस है, याद रखना। यहाँ पे इक्वली लेंथ है, तो अगर मैंने एज ए 2D लिखा, x equal to x1 plus x2 by 2 and y equal to y1 plus y2 by 2 as a complex number, z is equal to z1 plus z2 by 2, midpoint as a vector r vector, a vector plus b vector by 2, and as a 3D, x is equal to x1 plus x2 by 2 comma y equal to y1 plus y2 by 2 and z equal to z1 plus z2 by 2, right? So these are the formula for internal sections. Now external sections. Earlier I was teaching internal section. Internal section. I was teaching internal. जो पॉइंट आर था इंटरनल सेक्शन पॉइंट था, राइट? नाउ एक्सटर्नल सेक्शन। तो एक्सटर्नल सेक्शन में सपोज पॉइंट को ये मैंने पहले कॉल किया, बी को बाद में कॉल किया, ए इज कॉल फर्स्ट, बी इज कॉल सेकेंड, सो एक्सटेंशन विल बी beyond B. So let this is the section point C, external section point. ए को पहले कॉल किया था ए सी, दैट इज ए से सेक्शन पॉइंट तक एम, और बी से सेक्शन पॉइंट तक एन, या बी से सी एम बाई एन है। मैं सपोज कि बी पहले कॉल किया, लेट्स कॉल बी, देन कॉल ए, सपोज बी सी, लेट्स बी पी, देन ए पी, B calling first and A calling second. So extension will be before A. Okay. So this is your first section point. From here to here, it is M. First point to section point is M, and second point to section point is N. This should be remembered. Okay. This is very, very important. Now let's take PQ. Now I have to extend Q. So look, I have called P, then call Q. So let's complex number of P is Z1. Vector is A vector. Complex number 2D is X1 comma Y1. 3D is X1 comma Y1 comma Z1. In complex number this is Z2. In vector B vector, these are the position vector. 2D is X2 Y2, and this is X2 comma Y2 comma Z2. Complex number this is Z. This is R vector, X comma Y. This is X Y Z, right? The ratio of length from P to R, P point is first, Q to R. Ratio first will multiply with second, and second point ratio will multiply to first. This is the convention. Okay. Here I will find X 2D. So M will multiply with X2. For next cell I will take minus Y my2 minus ny1 m minus n. For complex number, z will be multiplied with z2, mz2 minus nz1 upon m minus n. And for vector r, m will multiply with b vector, n will multiply with a vector, divided by, for external both side minus, upside minus, downside minus. Okay. And for 3D, mx2 nx1 m minus n y my2 ny1 upon and zm z2 minus nz1 upon m minus n, right? I will not write lambda in terms of lambda for external, because we will use to find the ratio for external with the help of internal. Suppose that I used internal section formula and find lambda as a positive. If we use internal section formula, lambda positive internal section, then for lambda positive internal section, for lambda negative external section. Okay, so if we use internal section formula, to find ratio then for lambda positive internal section, for lambda negative external sections. Okay, right, these are the points. So internal distance formula all are done. Now different center in the triangle, different centers in the triangle. Different centers in the triangle. First, centroid. The point of intersection of medians is called centroid. I repeat, the point of intersection of medians is called centroid. Suppose that I have the point as a complex number Z1, as a vector A, as a vector, as a 2D x1 comma y1, as a 3D x1 comma y1 comma z1. Now this is the Q point. As a complex number, this is z2, as a position vector b vector, as a 2D x2 comma y2, as a 3D x2 y2 z2. The R point as a complex number, this is z3, as a vector c vector, as a 2D x3 y3, as a 3D x3 y3 z3. Let G is the centroid. G is the centroid. G as a complex number Z. G as a vector R vector. J is a 2D x comma y. J is a 3D x y z. आप आ रहे हैं? आ रहे हैं ना? ठीक है, सुना था ना जितना जिसको बोला था कि फर्स्ट हाफ में क्या करना, आधा घंटा बनाएगा ना, और जो मेमोरी बेस्ड क्वेश्चन है उसको टिक कर देने का ना, रख के रखने का, बाद में मार्किंग करना, ठीक है ना। पहले पूरे 120 क्वेश्चन आधे घंटे में पढ़ने का, जो मेमोरी क्वेश्चन हो लगा लेने का, उसके बाद 2 घंटे बैठ के जो तुम्हें लगता है पढ़ने के बाद पता चल जाएगा कहाँ सॉल्व होगा कहाँ सॉल्व नहीं, जो तुम्हें लग रहा है उसको सॉल्व करने का 2 घंटे में। तुमने पहले तुमने 10 क्वेश्चन कर लिया, अगर तुमने 35-40 भी किया, कितना किया 2 घंटे में, कितने बाद में 35-40 भी किया तो चलता है, कितना 40 करता है, ठीक है ना। बाकी फिर किसी से बात नहीं करने का, अभी से लेके गए, अभी से लेके कल शाम तक कितना, किसी से पढ़ाई की बात नहीं करने का, खेलने वाली बात करने का, घूमने की बात करने का, मस्ती वाली बात करने का, पढ़ाई नहीं करने का, बात नहीं करने का। अभी से किसे, अभी से लेकर कल शाम तक, एग्जाम जब तक खत्म ना होगा, बीच में भी किसी से बात नहीं करना। ना सेंटर किसी पे नहीं, किसी से नहीं, सेंटर तक में नहीं किसी से, क्या है, किसी से बात नहीं करना है। अपना माइंड कूल रखना, जो होगा देखेंगे, क्या है, ऐसा नहीं टेंशन क्या होगा ना, ऐसा कूल, क्या है, कूल रहो एकदम, राइट, क्लियर, एकदम कूल रहना अच्छे से। इतनी बात कहना था, ये बात की ध्यान रखना, हो जाएगा, ठीक, ध्यान दे, ठीक है। जो बोला है मैथ्स में कि पहला हाफ आवर है पूरे क्वेश्चन पढ़ने का, उसमें से 10 क्वेश्चन 120 में मेमोरी बेस्ड क्वेश्चन होंगे, को टिक करने का, बाद में मार्किंग कर लेने का, ठीक है। और बाद में जो 2 घंटे बचेंगे उसमें क्वेश्चन 110 में से सॉल्व करने का, ठीक है। वो 110 में से 40 भी सॉल्व हुए, कितने हुए, 2 घंटे, पर मिनट 2 क्वेश्चन, कितने, एवरेज, सॉरी पर मिनट 3, पर क्वेश्चन 3 मिनट, 40 क्वेश्चन, 40 से 120, ज्यादा नहीं सोचने का, करने का, ठीक है ना, फिर हो जाएगा, कटअप भी कर। हाँ, फिर इंग्लिश से शुरू करना, तो तुम्हारी इंग्लिश अच्छी है, इंग्लिश शुरू करना, इंग्लिश खत्म करना, पीसीबी का है, पीसीबी का ज्योग्राफी का है, ज्योग्राफी के बाद हिस्ट्री पॉलिटिक्स सिविक्स करना, ठीक है। ये बेस्ट स्ट्रेटेजी, और कोई दिक्कत, ठीक, ओके, राइट, ठीक, जा, बेस्ट ऑफ लक, ऑल द बेस्ट, ठीक है, ठीक, ऑल द बेस्ट, राइट। Now I will write x. So x will be x1 plus x2 plus x3 by 3, y equal to y1 plus y2 plus y3 by 3. For complex number, it will be z1 plus z2 plus z3 by 3. For vector r vector, a vector plus b vector plus c vector by 3. And for 3D, x equal to x1 plus x2 plus x3 by 3, y equal y1 plus y2 plus y3 by 2, 3. These are the things to be remembered. One more important things, let I have drawn median, B से D, I've drawn the median, Q से E, on the median, all. Let's I take here P, in place of P I will write for the convenience ABC. A, B, C, D, E, F. So AG upon GD equal BG upon GE equal CG upon GE. This will be your 2:1 from vertex side 2, from side 1. For vertex and 1, for side 2. These are the ratio, not length. They are the ratio, it's not a length. So no need to find a special cases for centroid, because centroid itself has special, because of very simple formula. So need to find a special case for this. Now formula for in center. In center, right? So suppose that I have a triangle. Now A, B, C. The angle bisectors of all the three angles where meet is called in center. Angle bisector. The angle bisector of the triangle, the point of intersection angle bisector is called in center. Okay. Here B2A and C2A is B2D, C2D. Here A to B2C, B2C or A to C. A to C divided by B to C, A to F, so B to F, and A to B, C to B. So A to E, C to E. These are equal ratios. Very, very important. Now let's take, suppose for 3D, for complex number Z, for vector R, for 2D x comma y, for 3D x comma y comma z. Now Z1 is as a complex as a vector. Let's write it is a small a1 vector as a vector. This as a complex number z1 or a vector a small b1 vector. Now I will write pq vectors. Let's write as a p vector, the q vector. This is as a z2, z3, z2. This is as a r. What should I take? Suppose that I will take a1 vector, a2 vector, a3 vector as a vector. AB length, BC length in front of A, that is small a. AB length is in front of C, that is small c, and AC in front of B, that is B. So by the formula I will write x equal for 2D. Let x equal to ax1 in 2D. This is suppose that x1 comma y1. This is x2 y2, x3 y3, and for 3D it will x1 y1 z1, x2 y2 z2, x3 y3 z3. So x1 bx2 cx3 divided by a plus b plus c, and y equal to a y1 by2 cy3. So bcj, a will multiply in front vertex, b will multiply with the front side, that is a small b will multiply the front vertex b, and a small c will multiply the front vertex, that is c vertex. Okay. So for complex number z, a small a will multiply the front vertex vector front vector z1, b front vector is z2, c front vector is z3, divided by a plus b plus c, and r vector, a front vector is a1 vector, b front vector is a2 vector, c front vector is a3 vector, right? 3D x equal to ax1 bx2 cx3 upon a plus b plus c y x ay2 ay1 by2 cy3 z az1 bz2 cz3 a plus b plus c, right? A special case, right angle triangle, right angle triangle, adjoint circle, will draw perpendicular at the contact point, perpendicular at the contact point, so this is the radius, this is the radius, so this is r comma r, right? Coordinate is r comma r. Suppose that this length is a small a, this is a small b, this is a small c. To find a small r, a plus b minus c divided by 2. Okay, there is one more formula to find the r, delta upon s, delta area of triangle, and a semi perimeter a plus b plus c by 2, right? Suppose that triangle is right angle, so this is already a and this is r, so coordinate will be a plus r, and this is b, so coordinate will, this coordinate will be b plus r. Okay, a plus r. The triangle, suppose that this way, and this way vertex is here, this is R, this is R. So this point will be from this. I will go back track minus R and down track R. For this, if this way, triangle is like that, this is the A comma B, this point will be, R will be subtracted and B will be subtracted for downside. For upside add, for downside subtract. Suppose that, yeah, good, no problem. So this is the in-center shortcut. Now, one more things I will explain. Then we'll go to the orthocenter, circumcenter, equilateral triangle. Okay, for equilateral triangle, suppose that Z1 is the complex number for vertex A, Z2 is the complex number vertex B, Z3 is the complex number vector C, sorry, vertex C. If Z1 square plus Z2 square plus Z3 square equal Z1 Z2 Z2 Z3 Z3 Z1 or 1 upon Z1 minus Z2 plus Z2 minus Z3, sorry, 1 upon Z1 minus Z2 plus 1 upon Z2 minus Z3 plus 1 upon Z3 minus Z1 equal to 0, right? Then triangle ABC is called equilateral triangle. Then triangle ABC is an equilateral triangle. Very, very important. This is the important thing to be remembered. Okay, right? Any problem? Then I will tell you perpendicular bisectors, circle equations in complex number. Right? These two are very, very important. That's why I'll give you as soon as possible. Then I will go on beyond. Will go on beyond. Okay, right? One point important. All coordinates of equilateral triangle cannot be rational. All coordinates of an equilateral triangle can't be रेशनल. मतलब ये है कि ट्रायंगल में एक्स वाई मिला के टोटल 6 कोऑर्डिनेट्स है, 3 एक्स कोऑर्डिनेट 6 कोऑर्डिनेट्स है, 3 एक्स कोऑर्डिनेट 3 वाई कोऑर्डिनेट्स. कांट बी, कैन नॉट भी अच्छे से लिखता, कैन नॉट बी. ऑल कोऑर्डिनेट्स ऑफ एन इक्विलैटरल ट्रायंगल कैन नॉट बी रेशनल. मतलब ट्रायंगल में टोटल 6 कोऑर्डिनेट है, 3 एक्स कोऑर्डिनेट 3 वाई कोऑर्डिनेट. तो सारे 6 के 6 कोऑर्डिनेट रेशनल नहीं हो सकते इक्विलैटरल के लिए. वेरी वेरी इंपॉर्टेंट, राइट? ये तुम्हारा ये हो गया. अब डिस्टेंस बिटवीन 2 पॉइंट इन कॉम्प्लेक्स नंबर तो बता ही चुके. तो परपेंडिकुलर बाइसेक्टर्स, इक्वेशन ऑफ पोलर बाइसेक्टर्स। परपेंडिकुलर बाइसेक्टर्स में सपोज कि मेरे पास लाइन सेगमेंट है Z1 ए पॉइंट और B Z2 दूसरा पॉइंट। एक मेरे पास एक कॉम्प्लेक्स नंबर वेरिएबल Z है सच दैट Z1 से डिस्टेंस और Z2 से डिस्टेंस सेम होना चाहिए। ये लेंथ सेम होना चाहिए PA। तो Z1 का लेंथ हुआ मॉड ऑफ Z माइनस Z1 जी PA का, और PB का मॉड ऑफ Z माइनस Z2, इक्वेशन ऑफ एंगल बाई परपेंडिकुलर बाइसेक्टर। दिस इज द, ये परपेंडिकुलर बाइसेक्टर है। पोलर बाइसेक्टर है। परपेंडिकुलर बाइसेक्टर वो होता है जो किसी लाइन सेगमेंट में परपेंडिकुलर भी हो और वो दिए हुए लाइन सेगमेंट को इक्वल पार्ट में ही बांट दे। तो लाइन सेगमेंट को इक्वल पार्ट में ही बांट दे और परपेंडिकुलर भी हो। तो ये भी लाइन सेगमेंट है, उस पे पी से पास करने वाला लाइन परपेंडिकुलर भी है और उसको इक्वल पार्ट में ही बांट रहा है ए बी को। तो पी से पास करने वाला लाइन है वो परपेंडिकुलर बाइसेक्टर हुआ। इक्वेशन ऑफ परपेंडिकुलर बाइसेक्टर। इक्वेशन ऑफ परपेंडिकुलर बाइसेक्टर। अब इसी को मैंने बोथ साइड स्क्वायर किया, जेड माइनस Z1 का स्क्वायर मान Z2 का स्क्वायर। यहाँ पे Z माइनस Z1 Z माइनस Z1 बार, यहाँ Z माइनस Z2 दूसरा Z माइनस Z2 बार, Z माइनस Z1 यहाँ Z बार अलग Z1 बार अलग, Z माइनस Z2 Z बार अलग Z2 बार अलग। मल्टीप्लाई किया मैंने तो जेड मॉड जेड स्क्वायर, जेड बार ही लिखते हैं, हाँ चलो, माइनस जेड से लिख देते माइनस Z1 बार जेड, फिर से यहाँ पे माइनस Z1 जेड बार माइनस माइनस प्लस जेड वन बार हो गया Z1 स्क्वायर मॉड, यार जेड बार मॉड जेड स्क्वायर माइनस Z2 बार जेड माइनस Z2 जेड बार माइनस माइनस प्लस mod Z2 square. So mod Z will be cancel out. Take this side. So 0, Z common, Z1 bar minus Z2 bar, Z, and we'll take this side plus Z1 minus Z2, Z bar plus Z2 is mod Z2 square minus mod Z1 square. So it will be Z1 minus Z2 Z bar plus Z1 minus Z2 bar Z mod of Z2 square minus mod of Z1 square. So let A Z1 minus Z2 as a complex number. So I can write Z minus Z1 bar as a Z bar A bar Z plus A Z bar, and for B I will write B is the real. B mod of Z2 square minus Z1 square. Real है ये. The equation of a straight line. Equation of straight line. Right? So slope. The slope equal to, yes, complex slope. I will write for this straight line. Equation of straight line complex slope is minus a upon a bar, and real slope is minus iota a plus a bar divided by a minus a bar. This is the real slope. So I told you about equation of a straight line, equation of perpendicular bisector. You should remember these things. Okay. You should remember complex slope and real slope. Then suppose that I have a circle with center Z0 and radius R. P point as a variable point, variable complex number. Z0 fixed, Z variable, R constant. So this is C. So CP is R. CP can be written as distance between Z and Z0. So mod of Z minus Z0 equal R. Equation of circle. Equation of circle with center Z0 and radius R. Right? I should not elaborate this further. Okay. I think I have completed your complex number for NDA purpose. One more things. I will take conjugates. Suppose that this is the conjugate Z. So conjugate Z will be mirror image in the x-axis. Mirror image in the x-axis. Mirror image Z bar. Mirror image of P in real axis. Right? Now I was dealing different centers. I went little drifted because of complex number. Now ortho center.
2 मिनट। अच्छा भाई क्या जब तक कर देता हूँ इसका जाओ नमाज पढ़ने में। हाँ हाँ, तो 2 मिनट छोड़ देता देन रुको ना, लेके जाना, मैं रुकता हूँ 2 मिनट में, रुको ना, हो गया। Point of intersection of altitude is called orthocenters. Okay, orthocenter is represented by 8. G centroid is represented by G, and in-center is represented by I. Orthocenter is represented by H. So how we will find this orthocenter here? One formula which is not useful. Here the useful things is, let's take H as xy. Then slope of H into slope of BC. Slope of BC -1. Slope of BH. Slope of CA -1. Slope of CH into slope of AB. Solve any two equations. We'll get orthocenter. Now a special case. A special case is the right angle triangle. The corner where right angle form in the right angle triangle is called orthocenter. The vertex of right angle triangle where right angle form is called orthocenter. That is like this. Right? So this will be your orthocenter. Now circumcenter. Circumcenter is the point
Point of intersection of perpendicular bisector. Point of intersection of perpendicular bisector. It's called circumcenter. Let's I join with I've joined with OA, OB, OC. Here OA equal OB equal OC equal capital R. Circumradius. Earlier small r was inner radius. Right? So again, you will write solve OA, OB and OBOC or OA, OB, OA equal OC or OA equal OC, OB equal OC. Solve any one pair. Solve any one pair to find circumcenter. Here you will take circumcenter will be represented by O. So it will take as a x comma y. A will be represented x1 y1. B will be taken as x2 y2. C will be x3 y3. Now the second method, slope of OD and BC. Slope of OD to slope of BC, this will be -1. You can find D as a midpoint of BC, okay? Slope of OE, slope of AC, -1. You can find E as a midpoint of AC, slope of OF to slope of AB -1. You can find F as a midpoint of AB. Solve any two equation. Solve any two equation to find circumcenter. Or take third method, x square plus y square plus 2gx plus 2y plus c equal to 0. On putting point ABC, after putting point A, B, C, find GFC. So center minus G comma minus F, radius under root G square plus F square minus C, right? A special method, a special case, right angle in right angle triangle. In right angle triangle, midpoint of hypotenuse will be circumcenter. So midpoint will be equally, this is called circumcenter. This is called circumcenter, okay? Now most special case, in equilateral triangle, all center lies at one point. All center lies at one point. So find centroid and tell it CN TRIOD and tell all type of center. Then all centers. Now one more important things. Suppose that I have orthocenter, then centroid, then circumcenter. This will be in 2:1. So H2 upon G2, 2:1. You have to apply this and find. If you have two centers given, you can find third centers. Okay, with the help of this formula. Now, ले जाओ. Swapnil, ले जाओ. Right. So I will leave it here because the next subject will start after this lecture. Okay, so I am stopping here. Okay, I am stopping here.
अरे लेक्चर में चालू है आज मैराथन रखेला 3 ऑनलाइन लेक्चर
जो दे दो.
हां ना चलेगा सुबह को ना ठीक है आपका नेट दिया था क्या
नहीं,
ये
इंस्टीट्यूट का नेट.
हां हां